this is all about ellipses. So ellipses, you're going to see some similarities between circles and ellipses. The only difference is with a circle, remember the radius is always the same in every direction. However, to make an oval, will we have the same distance every direction? No, we'll have one distance work one particular way and then one distance go the other way, and it's not going to be the same distance. That's what's going to make that oval. So you should hopefully see some similarities between circles and ellipses. A couple of new concepts, though, that we're going to be talking about today will be something called major axis, minor axis. We'll still have a center, so that won't change. And then also what we'll have something different called foci. So foci is kind of like the focus of a parabola in a weird way. So, so foci, again, is just talking about where is it kind of focusing around and so forth. So that's what we're going to be working on here. All right, so what is an ellipse? Well, an ellipse is just, again, a set of points in a plane. And again, that the sum of the distance from the two given points of the plane, called the foci, are going to be constant. And so the ellipse is going to have what we call two axes of symmetry. That means it can be cut this way and cut this way. And then also, we're going to have something called, again, the major axis and the minor axis. So in the table that I have here in your notes, A, B, and C are going to be related by the formula C squared equals A squared minus B squared. So that one you might want to underline because we're going to utilize that. That's for finding foci. So we'll get into that. And so the center, this is a little bit different here. So what are some of the same things that you see in the ellipse compared to the circle from yesterday? Yeah, we see the HK. Okay, still squared, quantity squared. Okay, what are some differences that you see? Yeah, they've got some division underneath. Okay, anything else? The big thing is what it equals to. It equals 1. So that's kind of the big kind of giveaway with an ellipse here. We always want to get that right-hand side to equal 1. And so we'll still have a center of HK. That's not going to change. What it means by direction of major axis, that's saying which way is my oval going. So is my oval going this way, so horizontal, or is it going this way, vertical? So you can have an ellipse going either direction. And then foci, these are our foci equations. We'll go through that in a little bit. So there's more than one focus, because remember how we talked about focus and parabola? So the plural focus is foci. So that's why. Almost sounds like a funky word. So, okay, major axis is going to be 2a units, so we'll talk about how you find the length. And then minor axis is going to be 2b. Now it depends. If my parabola is opening, or probably not parabola, ellipse is opening this way, your a squared and b squared can switch around. So what that means is your a squared has to be the bigger number. So we'll have to kind of look at our equations to kind of figure out which way is it opening. And so that will kind of help us with those particular parts. All right. So the first thing we want to do is write the equation for the ellipse. So, so that's what we're going to focus on first. And then after that, we're going to get into the actual solving piece because that's what we're going to do. You're going to spend more time doing problems like 4, though, than anything else. So you don't have to worry too much about dealing with the equation as much. So we're going to write an equation for each ellipse. So the first thing what we would have to do is figure out where do you think, if we drew in 2 lines of symmetry, where would be the center? So in this case, so this would be 1 line of symmetry here. So this is going to be what we call our major axis. See how it's longer? And then this one is going to be my minor axis. And you guys are right. They cross at 0, 0. So that's my center. So my center is at 0, 0. Okay. Now, to kind of get our equation, we're going to use that, and then we're also going to use the length of our axes here. So for our major axis, how long is it? 6 units. So what we really need to deal with is how much is half of it. Right. So the major axis, since it's 6, 2 times a is 6, so therefore my a value of my equation is going to be half of it, which is 3. Because it makes sense. You're going 3 units from the center, 3 units from the center, each way, left and right. My minor axis, how long is it? 4. So 2a equals 4, or not, pardon me, 2b equals 4. This is b, not a. And so therefore b would have to be 2 in length. This is enough now to write my equation. So we're going to have x minus h. What's h? 0. Do I really need it? No. So we can just say x squared over, now, take your a value and square it. So my a value is going to become 9. Then I'm going to have just y squared. I could write y minus 0 quantity squared if I wanted. And then I'm going to take my b value and square it. So 2 squared, which is 4. And then that equals 1. And then there's my equation, and I'm done. Okay? So that's an example of a horizontal ellipse. The next one, number 2, is a vertical ellipse. So this one's going to look slightly different, but not too horrible. So this is going to be, this time, this is my major axis because it's longer. And then this way is going to be my minor axis. So where is the center? Yeah, 0, 0 again. Not very original, but that's what it is. So my major axis is going to be this way. So then I have to figure out, well, how many units is that? So if this is at 0, 5 and this is at 0, negative 5, how long is it? 10. So therefore my A is going to be, how long? 5. Then my minor axis is the other direction. And so this one, it is going to be 8 units long. So 2b equals 8. Therefore b is 4. So now I'm pretty much ready to write my equation. And my equation is going to look a lot like the last one. So we're going to have x squared plus y squared. That's because of the 0. It's still going to equal 1. But this particular ellipse is going to be different because the A has to go under the bigger axis. And which way did it stretch more? Did it stretch more on the x-axis or on the y-axis? The y. So the A value is actually going to go under the y. So that's how this is a little bit different. So therefore, I take A and square it. So 25 is going to be under the y squared. It's not going to be under the x squared because that's where the minor axis was. And then to get this value, I'm going to square that 4, which will be 16. And so that will be my equation. So x squared over 16 plus y squared over 25 equals 1. Okay. Okay, last one. Again, same idea. This one, though, finally, we get something other than 0, 0 for the center. So this one is horizontal ellipse, so therefore, this one's a lot like example 1. So that's going to be your major. This will be your minor. Okay, this time let's figure out our center. So where is my center? So again, this is 0, 0 here, so 0, 2, yep. So there's my center. Then for, it's longer this way, so that will give me my A value. So my major axis of 2A is equal to 1, 2, 3, 4, 5, 6, 7, 8. So therefore A must have been 4. And then my minor axis is going to be, count it, 1, 2, 3, 4, 5, 6. So 2B equals 6, so B must be 3. And so to finish my equation, I'm not going to write x minus 0 quantity squared, so that's just going to be x squared again, plus, and then we're going to have, this time we actually have a number, so that's going to be y minus 2 quantity squared. Of course, it's going to equal 1. All ellipses equal 1. So do hyperbolas. And then to get our bottom number, since it opens this way, it's bigger on the x-axis. The bigger number, the A, is going to go under here this time. So we're going to square the 4. So we'll get 16. And then square the B value, which is 9. And then that's my equation. So that's kind of how you would write an equation of ellipse. The minus 2, very good. So because of the formula, remember how we had x minus h quantity squared and then y minus k? So this is k, 2, that's why it's minus 2. And so this just happens to be in the form of that's this, there. So that's where it's coming from. So it's just that we don't have 0, 0 this time, and the other ones we did. So let's get to the fun ones, because that's the ones that you need to do. So this is how this is going to relate to that we did on the board. So kind of think about the same things we did with a circle. It's kind of the same approach. What was our first step from yesterday? Split them. You're splitting the x's and the y's, but again, just on the left-hand side and so forth. So what should go after the 25x squared? The 50x. Okay, I'm going to leave a space. I'm going to have a plus 2y squared. Okay, what should go after that? Minus the 12y. What do I do with that negative 7? Move it to the other side. So that's going to become positive 7. Okay. So am I doing anything different than I did for circles so far? No. See, that's the fun thing about conics is once you get used to the process, you need to do the same process for pretty much all of them. Except for parabolas, you move the y's on the other side, but the process for the most part stays the same. So what do you think would be the next step? Because again, it's very similar to this. So remember, what do we do here? Yeah, we need to take out a value. So what am I going to take out of the x's? Yeah, you're just used to us doing the same number because remember it's a circle. But here, the numbers are not going to be the same. So this one I'm taking out a 25. So I'm going to have 25 parentheses x squared. 50 divided by 25 is 2, so 2x. And I'm leaving a space. Now, what should I take out of the y's? Because it's not going to be the same number. Take out a 2. So we're going to have y squared minus 6y. And leave a space, and then that's going to equal 7. Process is staying the same. We're not doing anything dramatically different. Just going to look slightly different. Okay? Now what should we do? Okay, we move the pieces around. We took out a number. What's next? Complete the square. So then I'm going to cut 2 in half and square it. So that's 1. And then this one I'm going to take negative 6 and cut it in half and square it. And then I got to figure out what the heck do I add to the right-hand side, and you got to account for that 25 and that 2. So 1, I didn't really add 1 to this side. I need to do 1 times 25. So I'm going to have to add 25 to it. And then what should I add from this piece? 18, because 9 times 2. Okay, are we good? Okay, so then I've got 25, let's factor this baby, so this would be x plus 1. Take out a 2 and factor this, so that would be y minus 3. And then I'm going to add this up and I'm going to get 50. Are we good so far? Okay, now remember all ellipses though don't equal 50. What do they equal? 1. So what do I have to divide by to make 50 become 1? 50. But if I divide that side by 50, I got to do the other side by 50. So everything gets divided by 50. And so now I'm going to just kind of clean this up a little bit. Really, what's 25 over 50? Because we can clean that up. So that's going to be, yeah, 1/2. So I can just put a 2 on the bottom. Is that okay? I'm not going to put a 1 on top. Don't need it. And then this is going to reduce as well. The 2 over 50, that totally reduces. So don't worry about the 1. What's going to become in the denominator? 25. And then this is going to equal 1. So now it's in our happy ellipse format. So now we should be able to pick this apart. So where is my center? So that'll be negative 1, 3. Okay, so we're going to graph that first. The board's off today. Okay, next step. look at our values underneath. Which number is bigger? So look at your two denominators. Which one's bigger? The 25. That's my a squared. So that tells me, does it stretch more on the x-axis or does it stretch more on the y-axis? Look at the letter above it, the y. So that tells me this is going to look like an egg. Okay, so sometimes you'll see when I like do the answer key, you'll see something like that. That's what I'm kind of trying to show you, is that it's going to be going that direction. So that tells me a squared is equal to 25. That tells me b squared is equal to 2. I want to solve that. So to find our major and minor axes, that's going to help me. So think about that. What number is in the a position then if a squared is equal to 25? So a is 5. So then, are we okay with that? A being 5. So remember what we did with circles? So that tells me that, now remember, that went to this. So that means I'm going on the y-axis up 5 and down 5. So go from your center, go up 5. 1, 2, 3, 4, 5. And then down 5. 1, 2, 3, 4, 5. Okay, so we've got in, this is my major axis. By the way, how long is my major axis? It's 10. Okay. All right, my minor axis, this one's not so much fun. So what would be b? So, well, we would have to square root the 2, right? So that would be the square root of 2, which is approximately like 1.4. Okay, so this one's not as much fun, but again, it's going under the x-axis, so you're kind of going like, you know, 1 and a little bit more. After that, I wish this, I don't want to stop to recalibrate this thing, but, and then draw your ellipse. Not the most beautiful ellipse I've done in the world. My minor axis would basically be about 2.8. Okay, the only thing that we did not cover, so did we find the center? Yes. Did we find the major axis? Minor axis? Foci? No. So let me show you the foci. That's the last piece. Okay, on the test, so you would want to be able to put all these things together. Okay, so for the foci, it depends which way your ellipse goes. If your ellipse goes this way, there's a particular formula for foci. If it goes this way, there's a different one. So that's why I typed them up nice in your notes. So if it is vertical like this one, you're going to have your formula for finding foci is both going to be h, and then what you're going to have next is it's going to be a different value. It's going to be k minus c and then k plus c. So I'm going back to here. So because it's this is the formula I'm using for that. So this is k plus c, k minus c. And you'd say, well, what the heck is c? Go back to that beginning notes. What is c squared equal to? It's kind of a funky form, but it's not Pythagorean theorem. So it's a squared minus b squared equals c squared. So we're going to calculate that. So c squared I don't know. I do know a squared, that was 25. I know b squared, which is 2. So we're going to have 23, and then that's c squared, so to get c, it's going to be the square root of 23. And so now to get my foci, my h is going to be the same number from my center. So my h is going to be -1 for both of them. And then to get the rest of it, I'm going to have my 3 from my center, from the k, but then one of them I'm going to add the square root of 23. And the other one I'm going to subtract the square root of 23. And then that would be my foci. And then we can figure out what they are by like plugging it into the calculator, but they're going to be decimals. I mean, it's not going to be really, really pretty. So one of these is going to be like -1, 7.8. So that's really, it's actually this, almost, it's like that red dot that I put in there. That's kind of weird. And then the other one is going to be 3 minus the square root of 23, which is negative 1.79. So that would be just a tad bit higher than that dot. So that would be your foci. Okay? So I'm going to pass out your worksheet. We're going to do some together to kind of get you started, just like what we did yesterday. Okay?